It's 11:47 p.m. on a Tuesday. You didn't get a warning. Not a real one. Your phone screamed. That emergency alert tone, the one that makes your stomach drop. You had 18 minutes. Maybe less. You grabbed your family. You ran to the bunker. The one you spent $11,000 on. The one the seller promised was nuclear rated. The one with the blast door. The hand crank air filter. The water barrel. The canned food. You sealed the hatch. You heard the detonation, felt it. The ground kicked like a horse. Dust fell from the ceiling. The lights flickered. Your kids screamed. Then silence. You made it. You think you made it. Here's what actually happened. Within 6 hours, invisible particles began creeping through a hairline crack in your ventilation intake pipe. A crack so small you couldn't fit a human hair into it. Doesn't matter. Radioactive fallout particles are measured in microns. A micron is 1/1000th of a millimeter. That crack? It's a highway. Within 12 hours, contaminated groundwater began wicking. That means slowly soaking, like a paper towel touching a puddle, up through the concrete floor of your bunker. Your concrete. The stuff you thought was a shield. It's acting like a sponge. Within 24 hours, the air inside your sealed bunker has a measurable dose of cesium-137 particles. You can't see them, can't taste them, can't smell them, but every breath you take is now delivering radiation directly into your lung tissue. Within 48 hours, you and your family are experiencing the first symptoms of acute radiation syndrome: nausea, metallic taste, fatigue. Your children, because they're smaller, are hit harder. Their cells divide faster. Radiation loves fast-dividing cells. Your bunker didn't save you. Your bunker killed you. Slowly. Welcome back, survivors. If you don't understand the science I'm about to break down for you today, every principle, every failure point, every invisible pathway that radiation uses to infiltrate a sealed space, you will not last 48 hours when SHTF. I don't say that to scare you. I say it because it's physics, and physics doesn't care about your receipt from the bunker company. Today we're going to tear apart the anatomy of why most underground shelters, most of them, the ones people actually buy and build, are not survival shelters. They are death zones. Sealed, underground death zones, where you will accumulate a lethal dose of radiation faster than if you'd stayed in a brick house above ground. That sounds insane. I know, but by the end of this blueprint, you'll understand exactly why it's true. And more importantly, you'll know how to fix it. Step by step, material by material, seal by seal. Let's get into it. Before I show you how to survive, you need to understand how you die. There are exactly 3 ways radioactive contamination enters a bunker. I call them the 3 seepage vectors. Think of them as 3 invisible assassins. Each one works differently. Each one exploits a different weakness in your shelter. In almost every bunker on the market today, every single shipping container conversion, every poured concrete basement, every corrugated steel tube buried in a backyard is vulnerable to at least 2 of them. Most are vulnerable to all 3. Let's break each one down. Here's what most people think. I seal my bunker. The air inside is clean. I'm breathing safe air. Here's reality. No bunker is truly sealed. None. Not even military-grade facilities are perfectly sealed. What military facilities have, and what your backyard bunker does not, is something called positive pressure over pressure systems. I'll explain that in the execution section. For now, understand this. The concept of a sealed room is a myth at the scale most civilians build. Why? Because of something called pressure differential. Let me make this simple. When a nuclear detonation occurs, it creates a massive blast wave. That wave compresses air. Then it pulls air back. This push-pull effect creates rapid pressure changes in the atmosphere above your bunker. Your bunker, underground, has its own internal air pressure. When the outside pressure spikes and drops, it creates a pumping effect on every single opening in your structure, every pipe joint, every hatch seal, every ventilation connection. Think of it like squeezing a plastic bottle with the cap slightly loose. Squeeze, air pushes in. Release, air gets sucked out. Now imagine that squeeze. Release happening multiple times in the first minutes after detonation, and then ongoing pressure fluctuations from fires, thermal updrafts, and weather changes for days afterward. Each squeeze pushes outside air loaded with fallout particles into your bunker through any imperfect seal. Now let me tell you how small fallout particles are. This is critical. After a nuclear detonation, the fireball vaporizes everything: soil, buildings, vehicles. This material gets sucked up into the mushroom cloud mixes with radioactive fission products, and then falls back down. That's fallout. It's not glowing green goo. It's dust. Fine, powdery, sometimes sandy dust. The most dangerous particles, the ones that stay airborne longest and travel farthest, are between 0.1 and 10 microns in diameter. For reference, a human hair is about 70 microns wide. These particles are 700 times smaller than your hair. Now look at your bunker's hatch. Look at the rubber gasket seal around it. Is that seal rated to block particles smaller than 10 microns? Probably not. Most commercial bunker hatches use standard industrial gaskets, the same kind used on submarine-style doors or industrial pressure vessels. These are designed to be water-resistant, not particulate-proof at the micron level. And that's just the hatch. What about the ventilation intake pipe? Most DIY bunkers use standard PVC or steel pipe. The joints are either glued, threaded, or welded. Glued PVC joints develop micro-fractures over time, especially when buried in soil that shifts, freezes, and thaws. Threaded joints are never perfectly tight. They rely on thread tape or pipe tow, which degrades underground within 3 to 5 years. Even welded steel joints can develop pinhole voids if the weld wasn't done by a certified professional using X-ray inspected passes. Each imperfect joint is an entry point. Each one lets fallout dust in. And here's the part that turns your bunker into a death zone. Once those particles are inside, they don't leave. Your bunker is a closed box. No wind, no rain, no natural dispersion. Every particle that enters stays. It settles on surfaces. You touch those surfaces, you breathe that air. The concentration of radioactive particles inside your bunker increases over time. It goes up, it never goes down. Not unless you have a system to actively remove them, and most bunkers do not. In the open air, fallout disperses. Wind carries it away. Rain washes it into the soil. But inside your sealed box, it accumulates. Your bunker becomes a concentration chamber. That's seepage vector number 1. This is the one nobody talks about. Everyone worries about the air. Almost nobody thinks about the water under their feet. Here's the situation. After a nuclear detonation, fallout settles on the ground surface. Rain falls, often within hours or days, because the massive heat and particulate matter from the detonation can actually trigger rainfall. This is sometimes called black rain. It happened at Hiroshima. It's real. It will happen again. That rain hits fallout, contaminated soil. It dissolves radioactive isotopes, primarily cesium-137 and strontium-90. These are the two most dangerous long-term contaminants from a nuclear weapon. Cesium-137 acts like potassium in your body. Your muscles absorb it. Strontium-90 acts like calcium. Your bones absorb it. Both emit beta radiation from inside your own tissues. For years, this contaminated rainwater soaks into the ground. It enters the water table, and now it's in the soil surrounding your bunker. But my bunker is waterproof, you say. No, it isn't. Let me explain something called capillary action. You've seen it. Dip the corner of a paper towel into a glass of water. Watch the water climb upward, against gravity, into the dry part of the towel. That's capillary action. It happens because water molecules are attracted to the tiny spaces between fibers. They pull themselves into narrow gaps. Concrete does the same thing. Concrete is not solid. Under a microscope, concrete is a maze of tiny pores and micro-channels. It's like a very hard sponge. Water moves through these pores slowly but relentlessly. This is called moisture migration, and it's a well-documented phenomenon in civil engineering. Every basement in the world that's ever had a damp wall or a wet floor is demonstrating this principle. Your bunker is made of concrete, or it's sitting on a concrete pad, or it has concrete block walls, water in the surrounding soil. Water that is now contaminated with dissolved radioactive isotopes will migrate through that concrete, slowly. Maybe a millimeter per day, maybe faster, depending on the mixed quality of the concrete, the presence of cracks, and the hydrostatic pressure. That's the weight of the water in the soil pushing against your walls. Let me put numbers on this so you understand the scale of the problem. Standard residential, grade concrete, the kind most contractors pour for basements and the kind used in 90% of civilian bunker builds, has a porosity of between 10 and 15%. That means 10 to 15% of the volume of your concrete wall is empty space, tiny channels, microscopic tunnels, air pockets left behind when the concrete cured. Now, military-grade hardened structures use specialized concrete mixes with chemical densifiers, water, reducing admixtures, and sometimes metal fiber reinforcement. Their porosity can be as low as 2 to 4%. Big difference. Massive difference. Massive difference. But even that isn't zero. Your backyard bunker? Your shipping container conversion sitting in a hole with a poured concrete pad? You're looking at standard mix. Maybe 3,000 psi if the contractor was honest. Porosity around 12%. That concrete is drinking groundwater like a slow, patient sponge. And here's the devastating part. The radioactive isotopes dissolved in that water don't just pass through. Many of them bind to the concrete itself. Cesium-137, in particular, has a strong affinity for calcium silicate hydrate, which is the primary binding compound in cured concrete. The cesium atoms lodge themselves into the crystal structure of your walls. They stay there. They emit gamma radiation, continuously. For 30 years. That's the half-life of cesium-137, 30.17 years. Your walls become radioactive. Read that again. Your walls. The things you built to protect you. They absorb the contamination. They become the source of radiation. You are now living inside a low-level radiation emitter. Every surface around you, floor, walls, ceiling if it's concrete, is dosing you 24 hours a day. This is why I call these bunkers death zones. Not because the fallout gets in and sits on the floor like dust you can sweep up, but because the fallout becomes part of the structure. It integrates. It's in the walls. You can't wash it off. You can't scrub it away. The cesium is bonded at a molecular level inside the concrete matrix, and you will never know it's happening. You won't see it, won't feel it. Not at first. The dose rate from contaminated concrete walls might be relatively low, maybe 0.5 to 2 millisieverts per hour. That doesn't sound like much. But you're living there, sleeping there, eating there, 24 hours a day for weeks, maybe months. That exposure accumulates. It's called cumulative dose. And at those rates, you cross the threshold for increased cancer risk within days. You cross the threshold for acute radiation syndrome within 2 to 3 weeks. All from your own walls. Now, some of you are already thinking, I'll waterproof my bunker. Problem solved. We'll get to waterproofing in the execution section, but I need to tell you right now, standard waterproofing is not enough. Tar coatings, rubber membranes, even spray on elastomeric barriers, they slow the water. They don't stop dissolved isotopes at the molecular level. And every waterproofing membrane has a lifespan. Underground, in contact with soil bacteria, freeze, thaw cycles, root pressure, and hydrostatic load, most commercial waterproofing systems begin to degrade within 7 to 15 years. When SHTF, you won't be calling a contractor to reapply your membrane. That's seepage vector 2. And it's the silent killer. This is the silent killer. This is the vector that even experienced preppers miss. Let me explain what happens after vectors 1 and 2 bring contamination into your bunker. Fallout particles enter through air leaks. Dissolved isotopes migrate through concrete. Now these contaminants are inside your living space. They're in the air. They're on surfaces. They're in microscopic water droplets condensing on cold walls. What happens next? Every material inside your bunker begins to absorb them. This is called sorption. It's the process by which one material takes in and holds particles or molecules from another material. It's the same reason your couch smells like cigarette smoke days after someone smoked in your house. The fabric absorbed the smoke particles. They're trapped in the fibers. Now replace smoke with radioactive cesium and strontium particles. Your sleeping bag, your clothing, your fabric, covered chairs, your cardboard boxes, your wooden shelving, your paper documents, your cloth-based air filters. Every soft, porous, fibrous material inside your bunker is acting as a radiation sponge, and here's why this creates a death zone multiplier effect. When fallout is outside, spread across miles of terrain, the dose rate at any single point is diluted by distance and dispersal. But inside your bunker, all of these absorptive materials are within inches of your body. You're sleeping on a contaminated sleeping bag. Your face is 6 inches from contaminated fabric. You're wearing contaminated clothes against your skin. The inverse square law of radiation tells us that dose rate increases dramatically as distance decreases. Cut the distance in half. Dose rate quadruples. Your bunker puts you in direct contact, zero distance, with contaminated materials. But it gets worse. Some materials don't just absorb radiation passively. They become what's called secondary emitters. Here's how that works. When certain materials absorb high-energy gamma or beta radiation, their own atoms can become temporarily excited. In some cases, particularly with materials containing trace metals, certain plastics, or mineral compounds. This absorbed energy gets re-emitted as lower energy radiation. It's like an echo. The original radiation hits the material, and the material rings with its own weaker radiation output. This effect is well documented in radiation shielding science. It's called secondary radiation or scattered radiation. In a medical X-ray room, for example, the walls are lined with lead specifically because lead absorbs X rays without significant ray emission. But the wooden chair in the corner, the plastic equipment housings, they scatter radiation. They redirect it. They spread it around the room in unpredictable directions. Your bunker is full of these scattering materials: wood, plastic, fabric, cardboard. Every single one of them takes incoming radiation and bounces it around your enclosed space like a rubber ball in a concrete box. This is why staying in an unprotected bunker can actually be worse than sheltering in a properly chosen above-ground structure. I know that sounds impossible, but consider this. A 2-story brick building with concrete floors has mass, lots of it. The upper floors act as shielding against fallout that lands on the roof. The interior rooms on the ground floor are surrounded by layers of brick, concrete, and air gaps. Fallout on the ground outside is kept at a distance by the building's footprint, the PF, protection factor, of the center room on the ground floor of a large concrete building can be 200 or higher. That means the radiation dose inside is 1/200th of the dose outside. Your underground bunker, on paper, should be better. Soil is an excellent gamma shield. 3 feet of packed earth reduces gamma radiation by a factor of 1,000. You should be safe down there. But that protection factor assumes the radiation stays outside. The moment contamination enters your bunker through air, water, or material absorption, your protection factor collapses. It doesn't drop from 1,000 to 500. It drops to nearly 1. Because the source is no longer outside. The source is inside, with you, on your walls, in your air, on your gear, against your skin. Your bunker's shielding is now working against you. It's trapping the contamination inside. The same 3 feet of earth that blocks outside gamma rays is now preventing the inside contamination from dispersing outward. You're sealed in a box with your own poison. That is what a death zone truly is. Not a place where danger comes from outside. A place where the structure itself becomes the weapon. All right, you understand the problem. 3 vectors, 3 ways your bunker betrays you. Now I'm going to show you exactly how to defeat each one, step by step, material by material. This is the execution protocol. This is what separates a death zone from a survival shelter. And I'm going to be extremely specific, because when SHTF, you won't have time to Google anything. We're going to address each vector in order. The goal here is simple to state and hard to achieve. You need to make your bunker a positive pressure environment with filtered air intake and 0 unfiltered leakage paths. Let me break that down. Positive pressure means the air pressure inside your bunker is slightly higher than the air pressure outside. Think of it like blowing up a balloon. The air inside pushes outward. If there's a tiny hole in the balloon, air leaks out, but air doesn't leak in. That's positive pressure. When your bunker has positive pressure, any small crack, any imperfect seal, any tiny gap, air flows outward through it, not inward. Contaminated outside air cannot push its way in because the inside pressure is always pushing out. This is exactly how military NBC shelters work. NBC stands for nuclear, biological, chemical. Every military bunker, every command post, every field hospital designed for nuclear warfare uses positive pressure. It's not optional. It's the foundational principle. How do you create positive pressure in a civilian bunker? You need 3 components. Component A, the blower. You need a device that pushes filtered air into your bunker faster than air leaks out. That's the blower. In military terms, it's called an NBC overpressure blower. In civilian terms, it's a fan with a specific job. Now, you cannot use a standard bathroom fan. You cannot use a computer fan. You cannot use a dryer vent fan. These are designed to move air at low pressure differentials. They spin fast, but they push weak. What you need is a centrifugal blower, sometimes called a squirrel cage blower. It's a specific type of fan where air enters the center and gets flung outward by curved blades. This design creates high static pressure. That means it pushes hard, even against resistance. Even against the resistance of a thick filter blocking most of the airflow. Where do you find one when SHTF? Scrap tech option. Every furnace in every house has one. The air handler unit in a residential HVAC system contains a centrifugal blower. It's usually a 1.3 to 1.32 horsepower motor attached to a squirrel cage wheel inside a scroll, shaped housing. Unbolt it, pull it out. You need the motor, the wheel, and the housing as one unit. 4 bolts usually, sometimes 6. A socket wrench or even a pair of pliers and patience will get it done. You'll need to power it. These motors are typically 120-volt AC. If you're running a generator, you're set. If you're on battery power, you'll need an inverter, a device that converts 12-volt DC battery power into 120-volt AC. Inverters can be scavenged from any large truck with a sleeper cab, most RVs, or any off-grid solar installation. You need at least a 600 watt inverter for a standard furnace blower. A 1000 watt inverter gives you safety margin. Connect the blower to your intake pipe. The filtered air, and I'll explain the filter in a moment, gets pushed into the bunker. Your bunker pressurizes. Air leaks outward through every tiny gap. Nothing gets in. That's the principle. How much overpressure do you need? Not much. Military NBC specifications call for a minimum of 0.3 inches of water gauge. That's an extremely small pressure difference. Imagine a column of water 1/3 of an inch tall. That's the pressure pushing outward from inside your bunker. It's barely enough to feel on your hand if you held it over a crack, but it's enough. It's enough to reverse airflow at every single leak point in your structure. Component B, the HEPA filter. The blower pushes air in, but that air comes from outside. Outside air is contaminated, so before it reaches the blower, it must pass through a filter that removes fallout particles. The filter you need is called a HEPA filter. HEPA stands for High Efficiency Particulate Air. By definition, by tested, certified, laboratory verified definition. A true HEPA filter captures 99.97% of all particles 0.3 microns in diameter and larger. Remember what I told you earlier. The most dangerous fallout particles are between 0.1 and 10 microns. A HEPA filter catches everything from 0.3 microns up. That covers the vast majority of the threat. The particles smaller than 0.3 microns, the ultrafine fraction, are actually caught at an even higher rate due to a physics phenomenon called Brownian motion. At that scale, particles are so small they move erratically, bouncing off air molecules, and they collide with filter fibers more often than the slightly larger 0.3 micron particles. So a HEPA filter actually performs better at the very smallest sizes. The 0.3 micron rating is the worst case size. It's the valley. Everything smaller and everything larger gets caught more efficiently. This means a HEPA filter is essentially a fallout particle wall. Nearly nothing gets through. Where do you get one? You can buy them now. Do it. A standard 24 by 24 by 24 inch industrial HEPA filter costs between $60 and $150. Buy 2. Store them sealed in plastic. They last indefinitely in storage if kept dry and undamaged. Scrap Tech Option Post, SHTF, hospital rooms, pharmaceutical labs, server rooms, and clean manufacturing facilities all use HEPA filtration. Find one. Remove the filter from its housing. They're typically held in by clamps or a friction-fit frame. Handle it carefully, don't crush it, don't bend it, don't get it wet. The filter media is a mat of randomly arranged borosilicate glass fibers. Extremely fine, extremely delicate. Damage the mat and you create bypass channels that particles can sail through. You must mount the filter upstream of the blower, meaning outside air hits the filter first, then the blower pulls it through and pushes the clean air into your bunker. This also keeps the blower motor and internal components clean. If you put the blower first and the filter second, the blower itself becomes contaminated. Every particle it touches becomes trapped inside the motor housing, irradiating the inside of your bunker from the blower unit itself. Order matters. Filter first, blower second, always. Component C, the sealed bypass prevention system. This is where 90% of DIY bunker builders fail, and this failure turns their entire positive pressure system into theater. A performance, a show that does nothing. You install the blower. Good. You install the HEPA filter. Good. But you left 3 other penetration points in your bunker unsealed. The exhaust pipe, the cable conduit for your antenna wire, the gap around your hatch seal where the rubber gasket has a fold, the spot where the plumbing waste pipe exits through the wall. Each one of these is an unfiltered opening. And here's the physics that kills you. Your blower is pushing air into the bunker. That air has to go somewhere. It will take the path of least resistance out. If your hatch seal is imperfect, and it is, air rushes out there. Great. That's overpressure working. But if your exhaust pipe has no check valve and your cable conduit has no seal, air rushes out there too. Now here's the problem. When the blower cycles off, because your generator runs out of fuel, because you're conserving battery, because the motor overheats and you need to rest it, the overpressure disappears. The bunker returns to neutral pressure. And in that moment, those unsealed penetration points become intake points. Contaminated air rushes in through every single one of them. Everything you accomplished while the blower was running is undone in minutes. This is why you need to seal every single penetration that isn't your filtered intake. Every single one. How? For pipe penetrations, use a combination of closed cell foam backer rod and non-hardening duct seal putty. Backer rod is a round foam rope. You can get it at any hardware store, and it lasts in storage forever. Push it into the gap around the pipe. Then cover it with duct seal, that gray clay-like putty electricians use. It never fully hardens. It stays pliable. It conforms to movement, and it provides an airtight seal. Scrap Tech closed cell foam backer rod can be replaced with strips of closed cell foam sleeping pad material, the kind from a camping pad, not an air mattress. Cut it into strips. Wedge it in. Duct seal putty can be improvised with a mixture of palitate. Let me give you a real-world alternative. Take petroleum jelly, Vaseline, and mix it with powderedite chalk or fine clay at a 1:30 ratio. Knead it like dough. It becomes a thick, pliable, non-hardening putty that seals gaps effectively. Not as good as commercial duct seal, but functional. And you can make it from scavenged materials in any abandoned pharmacy and any roadside clay deposit. For your hatch seal, this is your most critical seal. Most commercial bunker hatches use a single gasket, gone ring of rubber or silicone compressed between the hatch and the frame. When SHTF, you need to upgrade to a double gasket system. Apply a second gasket ring inside the first using adhesive-backed foam weather stripping. The dense, black, EPDM or rubber kind, not the fluffy white stuff. You want closed cell rubber. It compresses to seal. Open cell foam compresses to nothing and lets air through. Apply the second gasket ring 1 inch inside the first. Now when you close the hatch, you have 2 independent seal lines. If the outer gasket fails at one point, the inner gasket covers it. Redundancy. The same principle as double-hulled ships. One breach doesn't sink you. For cable and wire penetrations, do not run cables through open conduit. Every cable that enters your bunker must pass through a sealed gland. A cable gland, also called the cord grip, is a small fitting that clamps down around a cable and compresses a rubber ring against it. Completely airtight. They cost about $2 each. Buy a bag of assorted sizes. Scrap Tech. No cable glands available? Drill your penetration hole to be barely larger than the cable. Thread the cable through. Then seal both sides, inside and outside, with your improvised putty. Pack it tight. Smooth it flat. Then wrap the area with at least 3 layers of electrical tape pulled tight. Not duct tape. Electrical tape. It stretches and conforms. It creates a tighter seal on irregular surfaces. This is the hard one. If your bunker is already built and buried, your options are limited. I'll give you both paths, the pre-installation path and the post-installation retrofit. But I'll be honest with you, retrofitting against groundwater seepage is difficult, expensive, and imperfect. The best time to solve this problem is before the concrete is poured. The second best time is right now. Before SHTF, the principle is straightforward. You need to create a continuous, impermeable barrier between the contaminated soil and your concrete structure. The barrier must resist hydrostatic pressure, root penetration, microbial degradation, and chemical attack from dissolved isotopes. And it must last for a minimum of 5 years without maintenance, because after a nuclear event, cesium-137 in the topsoil remains dangerous for decades. But the most acute fallout danger diminishes significantly after the first 2 to 5 years through decay of short-lived isotopes and natural weathering. You need 3 layers, not 1, not 2, 3. Each layer serves a different purpose. Each one covers the weaknesses of the others. Remove any single layer and the system eventually fails. Layer 1, the densifier, applied directly to concrete. Before you wrap anything around your bunker, you need to change the concrete itself. Make it less porous. Close those microscopic channels I told you about. The material you need is called a penetrating concrete densifier. The most common type is sodium silicate solution, also called water glass. It's been used in construction for over 100 years. You brush it or spray it onto the concrete surface. It soaks in. It reacts chemically with the free calcium hydroxide inside the concrete. a natural byproduct of the curing process, and forms calcium silicate hydrate crystals. These crystals grow inside the pores. They fill them, they block them, permanently. One application of sodium silicate densifier can reduce concrete porosity by 25 to 40%. Two applications can push that to 50% or more. The capillary channels that were sucking contaminated water through your walls are now partially blocked at the molecular level. Where do you get sodium silicate? Hardware stores sell concrete densifier products under various brand names. The active ingredient is almost always sodium silicate or lithium silicate. Buy the concentrated version. A 5-gallon bucket treats approximately 1,000 to 1,500 square feet of concrete surface. Calculate your bunker's total exterior surface area, floor, walls, ceiling, and buy accordingly. Scrap Tech sodium silicate is also used as an adhesive in cardboard manufacturing. Any cardboard factory or packaging plant will have drums of it. It's also used in automotive exhaust repair products. Those gray putty sticks for fixing mufflers often contain sodium silicate. In an absolute emergency, you can extract a crude water glass solution by dissolving silica gel packets, the little do not eat packets found in shoe boxes, electronics packaging, and beef jerky bags, in a strong solution of lye. Lye can be made by running water through hardwood ash. This is crude, impure, but functional. The chemistry works. Apply 2 coats to every exterior concrete surface. Let each coat dry for 24 hours. The concrete will darken slightly. That's normal. That's the reaction happening. Layer 2. The membrane, applied over the densified concrete. This is your primary water barrier. A continuous, flexible, waterproof membrane bonded to the exterior of your bunker. The gold standard is a 60 ml HDPE geomembrane. HDPE stands for high-density polyethylene. It's the same material used to line landfills, engineered specifically to prevent contaminated liquid from migrating through it. A 60 ml sheet is about 1/16 of an inch thick. Tough, flexible, chemically resistant. A properly installed HDPE liner has a projected service life of over 100 years in soil contact. You wrap your entire bunker, floor, walls, and top in a continuous sheet of this material. Every seam is heat, welded using a specialized tool that melts the 2 overlapping edges together, creating a bond as strong as the original material. No glue, no tape, heat, welded. Scrap Tech alternative. If you cannot source HDPE geomembrane, your next best option is pond liner from agricultural supply stores. It's the same material, often the same thickness, sold for farm ponds and irrigation reservoirs. Cheaper. Widely available in rural areas. Same performance. If neither is available post-SHTF, your emergency fallback is multiple layers of 6 ml polyethylene sheeting, standard construction plastic, with the seams overlapped by 12 inches and sealed with a thick bead of polyurethane caulk between layers. This is not as good. Poly sheeting is thinner, more puncture-prone, and degrades faster underground. But 4 layers of 6 ml poly with sealed overlaps will outperform bare concrete by a factor of 1,000. It buys you years. Critical installation detail. The membrane must extend at least 18 inches above your anticipated soil grade line. Water doesn't just come from below. Surface runoff, contaminated rainwater, flows along the soil surface and down along the exterior of your bunker walls. If your membrane stops at ground level, that runoff gets behind it, flows down between the membrane and the concrete, pools at the bottom. Defeats the entire purpose. Extend the membrane up. Seal the top edge with mechanical fasteners and caulk. Keep surface water on the outside of the barrier. Layer 3. The drainage layer, installed outside the membrane. Water is persistent. It finds pressure. It pushes. Even the best membrane can be compromised if hydrostatic pressure builds up against it for months or years. You need to relieve that pressure. Give the water somewhere to go that isn't through your barrier. Install a drainage layer outside the membrane. This is a layer of coarse, clean gravel, washed stone, 3/4 inch to 1 inch diameter, at least 6 inches thick, surrounding the entire bunker. At the base of this gravel layer, install a perforated drain pipe, standard 4-inch perforated PVC wrapped in filter fabric to prevent soil clogging. This pipe should slope, a minimum of 1/8 inch per foot of run, toward a discharge point downhill from your bunker, or toward a sump basin that you can pump out manually if needed. The gravel allows groundwater to flow freely around your bunker without building pressure against the membrane. The drain pipe collects it and routes it away. Hydrostatic pressure drops to near zero. Your membrane doesn't fight the water. It simply stands there, unburdened, doing its job. This is the same system used around every properly built basement foundation in the world. It's proven. It's simple. It works. Scrap tech, no gravel. Use crushed concrete rubble. Demolished buildings produce mountains of it. Break it down to fist-sized pieces. It performs identically to natural gravel for drainage purposes. No perforated pipe? Take standard solid PVC pipe and drill quarter-inch holes every 6 inches along 2 rows on opposite sides. Wrap it in landscape fabric or even an old cotton bedsheet to act as a soil filter. Crude. Effective. This is the fastest fix. And the most overlooked. The rule is absolute. Eliminate every porous, absorptive material from inside your shelter. No cardboard. Replace with sealed plastic bins. Hard-sided. Snap, lid. Wipeable. No fabric furniture. Replace with metal or hard plastic seating. A folding metal chair with a wipeable vinyl cushion is infinitely safer than an upholstered couch. No cotton sleeping bags. Use a metallized emergency bivvy, the crinkly silver kind. Non-porous, non-absorptive, wipeable. Weighs 4 ounces. No paper goods stored loose. Seal all paper, books, documents, maps, manuals, inside zip, lock bags. Double bagged. No exposed wood shelving. Seal all wooden surfaces with at least 2 coats of polyurethane varnish. This fills the wood grain pores and creates a non-absorptive surface. If you can't varnish it, wrap it tightly in plastic sheeting and tape the seams. Your air filter, the cloth pre-filter many people install in front of their HEPA filter, must be considered a contaminated item after use. Never shake it out. Never reuse it without understanding that it's now a concentrated radiation source. Bag it. Seal it. Move it to the farthest corner of your shelter or, better, push it out through your exhaust port and away from the bunker. Every interior surface, walls, floor, ceiling, should be coated with a washable, non-porous finish. Epoxy paint is the best option. 2-part marine epoxy applied in 2 coats creates a glass, smooth surface that doesn't absorb particulates and can be decontaminated with a damp cloth. Scrap tech, no epoxy paint? Standard oil-based porch enamel provides a reasonable non-porous surface. Glossy finish. Hard, wipeable. Available in any abandoned hardware store. 2 coats minimum. Let each coat cure for 48 hours. The glossier the finish, the less absorption. Here's the secret that almost nobody teaches. Even with all 3 vectors defeated, filtered air, sealed walls, non-absorptive interior, you still have one critical vulnerability. It's you, your body, your skin, your hair, your clothing. Every time you open that hatch, to check conditions, to retrieve cached supplies, to dump waste, you expose yourself. Fallout particles land on your clothes, in your hair, on your skin. You close the hatch, you climb back in, and you just carried contamination past every single layer of protection you built. You are the breach. This is why every military NBC protocol includes a decontamination procedure before re-entry, and this is the step civilians almost universally skip. The fix is simple. Dedicate one set of clothing as your outside suit. Put it on before you open the hatch. When you come back in, remove it at the entry point, every piece. Bag it in plastic. Leave it near the hatch. Then wipe exposed skin, face, hands, neck with damp cloths. Not dry, damp. Dry wiping just spreads particles around. Damp cloth captures them. Use clean water. Wring the cloth outside the living space. This alone reduces internal contamination by an estimated 90% compared to re-entering your shelter in exposed clothing. One more mistake. The big one. The one that kills people who think they did everything right. Your bunker's intake pipe opening. The one where outside air enters before hitting your HEPA filter must be positioned correctly. Most people run the pipe straight up to the surface. Vertical, open end pointing up. Like a chimney in reverse. Do not do this. Fallout settles downward. An upward-facing pipe opening is a funnel. It catches falling particles. It concentrates them directly at the filter face. Your HEPA filter will clog in days instead of weeks, and once it clogs, your blower can't push air through. Overpressure fails. Your bunker returns to neutral. Every unsealed crack becomes an entry point. All 3 vectors reactivate simultaneously. Instead, run the intake pipe so the opening faces downward. Like an upside-down J, the pipe comes up vertically, bends 180 degrees, and the opening faces the ground. Falling particles cannot enter a downward-facing opening by gravity alone. Wind-driven particles are deflected by the bend. A simple stainless steel mesh screen, window screen grade, across the opening, stops insects and large debris without significantly restricting airflow. This one detail, the orientation of a single pipe opening, can be the difference between your filtration system lasting 8 days or 8 weeks. Between surviving the critical fallout period and having your HEPA filter fail on day 4 while cesium-137 is still raining from the sky. The details matter. Every detail matters. When SHTF, there is no margin for close enough. Let me leave you with this. A bunker is not a product. It's not something you buy and forget. It's not a receipt in a drawer that guarantees your survival. A bunker is a system, a living, breathing system of seals, filters, barriers, and protocols that must work together, every component, every connection, every detail, or it becomes the most expensive coffin you'll ever buy. Most people who build bunkers are building death zones. Not because they're stupid, but because they don't understand the science. They don't understand that concrete breathes. They don't understand that sealed doesn't mean sealed. They don't understand that the threat isn't the blast. The blast lasts seconds. The threat is the invisible, odorless, tasteless poison that seeps through every imperfect joint and porous surface for weeks and months afterward. Now you understand, you know the 3 vectors: airborne infiltration, groundwater capillary action, material absorption, and secondary emission. You know how to defeat each one. Positive, pressure-filtered ventilation. 3 layer exterior barrier systems, non-absorptive interior surfaces, and decontamination protocols. You have the blueprint. What you do with it is up to you. But I'll tell you this, and I mean every word. Knowledge is the only gear that doesn't weigh you down. It doesn't rust. It doesn't expire. It doesn't break when you drop it. It doesn't need batteries. It rides in your skull, and it works on demand, every single time. The people who survive when SHTF won't be the ones with the biggest budgets. They'll be the ones who understood the science, who studied the details, who knew that a pipe opening facing the wrong direction could end their entire family. Study the blueprint. Stay out of the death zones. I'll see you in the next one.